right, well, let's let Bryan get settled. While we wait this last minute, go ahead and get your questions ready. Reminder that you're invited to post questions to Twitter with the hashtag #NeedToKnow. All right, so it's 5 past the hour. Bryan, you ready to get started?
Let's do this.
All right, fantastic. So welcome everybody once again to Need to Node, webinar series from NodeSource. Every month we gather topics that are of interest to developers, DevOps, and engineering management that help us improve the way we build Node.js applications. So this month we have a very special guest, Bryan Hughes of Microsoft, is joining us, and he's going to share his experience learning and integrating TypeScript into his workflow with all the stuff that he's been doing there at Microsoft. So I'm going to hand it off to Bryan, and I'll see you in about 40 minutes for questions and answers. Thanks, Bryan.
All right. Hi, everyone. As Dan said, my name is Bryan. I've been at Microsoft now for about 4 months, and there I do Node.js tooling is what I work on. And so I write TypeScript all day, every day. I am fairly new to TypeScript specifically, but I have a long history with languages. Back when I was working on my PhD, I did a fair amount of language theory and things of that nature. And when I started programming, I did C++. I did primarily C++ for probably 10 years or so. And then I kind of throughout that, I also did some Java, some C#. I did Java for a while as well. So, I come from, the statically typed language background. But then I switched to JavaScript around 2010 or so, and including Node. And so I've been doing Node.js for, some time now, and JavaScript. And so in a way, TypeScript was sort of like coming back home. And so, I'm going to talk about what it's been like, learning TypeScript from, my perspective as someone who came from a statically typed background, but also from someone who comes from a JavaScript background. And the first thing, though, is what is TypeScript? So TypeScript has it's several things. It is a statically typed language. For those of you who are, purely from the JavaScript world or maybe the Python or Ruby world, what static typing means is when we declare a variable, it has a specific type associated with it, a string or a number or something like that, and it can't ever change, unlike in JavaScript. TypeScript also has classes and interfaces. These are pretty similar to classes and interfaces in Java and C#, things like that. TypeScript does have a module system. And finally, TypeScript is a compile-to-JavaScript language. So the workflow looks a lot like if you're using ClojureScript or CopyScript or even ES6 through Babel or something like that. So let's kind of look at some code. So first, let's look at how we do type declarations in TypeScript. Here we have a very simple function that takes a first name and a last name, 2 strings, and combines them together. And so this is basically JavaScript. It looks like we're familiar, but we can see there's these little type annotations. And a type annotation is just anytime we have a variable declaration or a parameter in a function, we add a colon and a space and then the type after that. So in this case, everything is a string, and they can only be strings. So we create this first name variable, this last name variable that are strings. We assign strings to them, and then we pass them around. And so this executes just like regular JavaScript. But the TypeScript compiler is going to go in and make sure that things are always strings. And so if you try to assign the number 10 to first name, TypeScript would actually give you a compile error. You wouldn't even be able to build your project. So it catches that mistake really early on. TypeScript also has the concept of an interface. And an interface is kind of a type that is for more complicated variables, something that aren't just primitives. And so in this case, we have an interface in which we say there's an object. This object is going to have 3 properties on it: first name, last name, and age. And then we also say the type for first name, last name are both strings, and age is a number. And so then whenever we're passing an object around, an object literal or something created from a class, we can make sure that that object conforms to this contract that the interface provides. And so in the case of an object literal, this will check to make sure that we assigned a string to the property first name. It will also make sure that we added all of the properties that are necessary. So if we left off age in this object fry, for example, it would throw us an error. And also, if we added a property that was not defined in the interface, it would also throw an error. And so this is really valuable at detecting typos, for example. I think we've all been there in JavaScript where we have an object literal and we misspell a property name. And then we hope that this is caught in unit testing, but maybe it's not. Maybe it slips into production and we get some very strange, quirky bug. But with TypeScript, that gets caught at compile time immediately, and it says, hey, this property isn't there. You should probably check that out. There's also classes in TypeScript. They're really similar to ES6 classes if you've used those before. In fact, the ES6 class specification drew very heavily from the TypeScript specification. But there are a few extra kind of features in TypeScript classes. The first is visibility. So we have a couple of properties here. We have a getter called name, and we have a method called takeoff. But then we have this little public and private in front of it. And so if you're familiar with Java, C# and those languages, this should be really familiar to you. But if you haven't, the basic concept of visibility here, public and private, is that anyone can access a public method. If someone has just a reference to an instance of this class, they can call that method. But if it's private, what that tells us is that only methods within that class can call it. So this is pretty similar to using symbols in ES6 if you played with those. And this is really handy for having helper methods and things like that, things we would traditionally use like an underscore prefix method for. But except in this case, it's actually private. It's literally impossible for someone outside of that class to reference it. Classes can also implement interfaces. So once again, if you're familiar with Java and C#, this should look pretty familiar. What this basically says is we have a class with some implementation, and it's going to conform to this interface contract. Now, this is a little different than object literals. When we have a class that conforms to an interface, it can have extra methods on it or properties and things like that, which that is different than object literals. And so this is how we get like our helper methods and things like that. Using an interface for a class can be really handy if you have multiple class implementations that all conform to the same thing. You can also do this with base classes. There's a couple of different ways of managing that. So for example, if you have a class for different types of cars, you can have a car class, a truck class, a motorcycle class, and they could all conform to the same interface. And this way you can pass the interface around and use it in your type definitions and other functions and things of that nature. TypeScript also has modules. So TypeScript has gone through a couple of iterations on modules. As it turns out, there are, I believe, 3 different ways of declaring modules. And a lot of this is just for historical reasons, as the JavaScript community itself has kind of been figuring out how to do modules. It kind of tracks the evolution of the ES6 module spec. And the preferred de facto way of doing modules in TypeScript, though, is to use the ES6 module spec, which is exactly what we see here. And so if you're not familiar with it, it can be thought of as kind of similar to CommonJS in that you export different things in your module. But there are a couple of key differences. The key difference, formally speaking, is that the ES6 module spec is what's called a multiple import-export system, whereas CommonJS is a single import-export. In CommonJS, you require some module and you get an object back, or whatever was exported. If you want to export multiple things, you add those as properties on that object. Whereas in ES6 modules, you can actually directly export multiple things. And we do that using the export keyword. So in this example, we are exporting a single class called ship, and we're saying that this ship implements this interface, which was defined in a different file somewhere else. It is possible to export multiple things. You can import multiple things as well. In this import statement at the top, you can see we have these curly braces. And in that's where we define the names of the variables that we're importing things to, or the names of the symbols, I should say. And so you can have a comma-separated list of multiple ones if you prefer. There's also in ES6 modules, there's the concept of a default export. You can say export default, const foo or something. And that way, in that case, what you do is you would say import some name without the curly braces from your, and that's a little more similar to how CommonJS works. So that's kind of the basic features, it kind of give me a little taste of what TypeScript looks like. There's a lot of other features and details in it, but that's kind of the day-to-day stuff that I tend to use. So what are some of the benefits to using TypeScript? Well, the biggest one, and I've hinted at this already, is type safety. And, the compiler is checking to make sure that our code conforms to a lot more rules than the basic JavaScript static analyzer, the VM checks. You got to make sure that all these types are fitting around right. And the biggest advantage we get from this is that it reduces typos going out into code. Because most of the time when you make, most of the common typos at least are going to be caught by the compiler. So they're caught, right as soon as you build, instead of maybe slipping in and hopefully you catch it in your unit test, but not always. And so that saves developer time. Another big one is it reduces mistakes when you're refactoring it, which, this is a very specific type of typo. This is a very common one. You have some module that exports a method, and let's say you change the signature. You add an extra parameter to it, or maybe you switch from having 3 parameters to an object with properties, or something like that, or you rename a method. So in JavaScript, in practice, the way we end up doing this is we just sort of like grep our code base, and we have to sort of like look at every instance and say, well, is this it? Is this not? And we hope that we haven't aliased this function to some other variable, because then it gets even more complicated. And so refactoring in JavaScript is kind of non-trivial, and it's non-trivial in other dynamically typed languages as well. And so, as the code base grows, we tend to develop sort of a fear of refactoring, and I think that's a healthy fear in JavaScript, just because it increases risk of bugs shipping into the final product. But when you have a statically typed language like TypeScript, it's a little different because we can actually know 100% if we are going to break something when we refactor, or we can have 100% confidence that when we refactor something that we have actually refactored it properly in all cases, because this now becomes a compile time issue instead of a runtime issue. And I think this is one of the biggest strengths of TypeScript right here is when it comes to refactoring easily, because it reduces bugs, and once again, it really reduces developer time, so we don't have to spend as much time testing and things like that. And it also gives us more confidence to do, architectural upgrades and things like that as the life of the project goes on. And it can help, keep technical debt a little bit lower as well. And so, like refactoring, I kind of talked about that some. Let's look at it a little bit in practice. So these are some screenshots from Visual Studio Code, a cross-platform text editor that I use all the time, as do a number of people. And this is kind of what refactoring looks like. We're taking that interface example we saw earlier, but then we decide that, okay, maybe having the word name in there is a little bit superfluous, so we're just going to change it to first and last. So within the editor, we can just right-click on first name and say rename. We change it to first. And because TypeScript is statically typed, Visual Studio Code and other code editors can look at your code and find every single instance and rename it for you. So, this refactoring name now takes all of 10 seconds, which is very, very powerful, and it really saves a lot of development time, I found. So what are some of the ideal use cases? TypeScript is great for a lot of different projects, but where it really shines, I think, is when you're working on larger teams, larger projects, and then people like myself who came from statically typed languages. So when you're working on a large team, you're dividing up code between a lot of different developers. Oftentimes one person will be responsible for a certain area. So there's a real importance to define kind of almost internal APIs between developers, sort of informal internal APIs. And in traditional JavaScript, the way we do this is, someone will write a module. We hope that they write documentation, but we all know how development goes. Sometimes we are in a rush to meet deadlines, and so we kind of skimp on the documentation. And so then someone coming in who needs to figure out how to use your module will look at this module and say, well, how do I use it? There's this method here called get or something, get name, let's say, and it takes a single argument called options. Well, what are those options? In traditional JavaScript, if this isn't documented, that basically means then you have to go in and read the code, or you have to go bug the developer who wrote it and say, hey, how does this work? Learning how code works is a communicated aspect outside of the code. But with TypeScript and other statically typed languages, you have to have a formal spec for this. you have to say, okay, there's this object, it has these properties with these types. And so now you don't have to dig through the implementation to figure out what its parameters are, at least in a lot of cases. And so it can serve as at least partially self-documenting in a lot of cases. And so, reduce communication or the need for communication between developers and things like that, and you can focus more just on writing code. It also the TypeScript benefits larger projects. So as a project grows, we have modules that sit around doing a lot of things, especially helper modules, and they can be used all over the code base. At previous jobs where I worked on large-scale applications before, it wouldn't be uncommon for a module to be used in 50 other modules. And once you get to that kind of scale, if it's in raw JavaScript, there's a very healthy fear of ever changing it because it's just used in so many places, and the chance of making a mistake is very, very high. And so that's an unacceptable risk. But once with TypeScript, when it comes time to refactor something in a large project, you can do it with confidence that you're not going to break your product. And so it helps you to really scale a project to larger and larger sizes. Another thing I've noticed, and I'm kind of speaking a little more from personal experience on this one, is that people who are coming from statically typed languages get very used to the tooling you have around that. Visual Studio is well known for its tooling. People who use C# talk a lot about how great Visual Studio is. And I think it's good for those use cases as well. And there are other great editors out there as well. Eclipse is really good for Java, and JetBrains has some really good products as well. And so, coming from that statically typed background, we kind of got used to those tools. And I remember when I first started using JavaScript, I was almost kind of scared to write code because I felt like I was coding without a safety net for the first time. And it made me kind of not like JavaScript as a result, and just made me a little uncomfortable. And TypeScript is a really good way to provide a good place for people coming to these languages to land in the JavaScript kind of world. So this is great, especially in the Node world, where let's say there's a backend written in .NET or Java, and you want to migrate to Node, but you have an existing set of developers who are Java and .NET developers. By using TypeScript, it's going to make that transition for the team quite a bit easier, because it's giving you these developers more familiar tools and things like that. So I've kind of talked about types a little bit, but I want to dive into how types in TypeScript work a little bit more in depth, because I think it's really important to understand in using TypeScript effectively. So types in TypeScript are really native JavaScript types. There are 7 types in JavaScript. These are undefined, number, string, boolean, object, function, and a symbol, with symbol being the latest type that was added in ES6. And that's all the types there are in JavaScript. And it turns out that's all the types that there are in TypeScript as well. TypeScript doesn't add any of the other types you often will see in a statically typed language. For example, in C++ especially, there are a few dozen different types of number types. You have floating points, you have double wide floating point, you have unsigned integers, you have signed short integers, and all these different types. But TypeScript actually skips all of that and says, nope, we get the exact same types that are in JavaScript. So if you have an understanding of the base types in JavaScript, you already know the types that TypeScript uses. And specifically looking at classes as well, TypeScript classes don't behave like C# or Java classes, which are sort of a classical inheritance model. They actually behave like JavaScript classes. The class itself is also an object, and then instances of classes are just different objects. And it uses prototypal inheritance, and all of that kind of typical thing. So if you're familiar with JavaScript, TypeScript really just feels like a little bit of syntactic sugar on top of JavaScript. One of the big goals that we have with the language is to make it feel comfortable and familiar to JavaScript developers. And TypeScript is also opt-in. So you can add types, but you don't have to annotate everything in your code base. And so what this means is that vanilla JavaScript is also TypeScript. And so this is really handy if you want to migrate an existing code base from JavaScript to TypeScript, because you can import that code base, and for the most part, it will just work as is. You don't have to make any changes. And you can work on upgrading bits and pieces of it over time, as time becomes available. And so in this case, what happens is, we have a non-inferable type. We just do var x, semicolon, and then we use that later in our code. TypeScript will assign this a static type of what it calls any. And this is a special type that basically says this can take on any type. And so then this variable acts like a typical variable in JavaScript. You can assign it a string, and then on the next line assign it a number, and then the next line assign it an object. And so this really makes it easy to transition. And there are other benefits in using this as well. Sometimes adding types can be just a little bit of overhead in TypeScript. Another thing to understand about types in TypeScript is that TypeScript will try and infer a type whenever possible. So let's say we create a variable called x and we assign it a number 10. Well, we know that that type is now going to be numbered because, once again, types can't change their length. And so TypeScript, when possible, will actually add this type in. Now, it only does it in select cases when it can know for certain. So with pretty much this only happens with primitives, although it can do a little bit with objects around this. But this is really handy as well because one of the big complaints against C++ and Java, and I think a valid complaint, is having to constantly write out types all the time can get really cumbersome and at one point can start to impede developer productivity a little bit. And so TypeScript is pretty smart about doing this for you. You only have to add types whenever TypeScript can't figure out on its own. All right, so I talked about TypeScript as a generic language, but how do you actually use TypeScript with Node.js? So we're going to look into the tooling around TypeScript and how you integrate that into your workflow. So first, there is a compiler. And this we use npm for everything. You can install TypeScript, with npm install -g TypeScript. You also need to install a thing called typings, which we'll come back to a little bit. This second line here, this typings install source dt global node thing, we'll come back to that a little bit. But basically, we're saying that okay, we're going to have a TypeScript project, and we want to use the node bindings for it. And you can also specify the node version you want. And then once we have the tools installed, you can run the command tsc, which is short for TypeScript compiler. We give it a destination directory where we want our compiled files to be put. We say we want this to be compiled into the common.js format, and then we give it the names of the files that we want to compile. TypeScript is pretty flexible, so you could also compile it to the required JS format if you're using AMD, and there's a few other options in there as well. So I showed that to you in a command line, but you can also create a configuration file, much like you can create a Babel configuration file. And this file is called tsconfig.json, and this is pretty typical options that you see. There's a few compiler options we're going to give it. We're going to say we're going to use the common.js module format. Once again, we see outdoor, where we want the destination to be. And then we also have the source map entry, in which we say we want to enable source maps. For those of you who haven't worked in compiled to JavaScript languages before, a source map is a little bit of extra metadata that can get embedded into a source code file that tells you how the compiled code relates back to the original TypeScript code. And also you can do this with CoffeeScript and ClojureScript and Babel and a lot of the others. And most of the debugging tools out there, like the Chrome Inspector, Node Inspector, and Visual Studio Code, when you're debugging, will actually show you the original TypeScript code as well. So it's a very handy thing to enable for development. And there's a lot of other options too. You can read the documentation to see how you can really kind of tightly control how things are compiled. And then we also have an exclude directory. And so when we look at this configuration file, it's essentially going to look at your project directory, find whatever TypeScript it can, and we'll compile each file one by one into its JavaScript version and create a sort of identical code tree inside this directory. And if you wanted to pair this with, for the browser something else, you could then chain it into Webpack or Browserify to get it into a single compiled output. So linting is a thing that we all like to run, and there's a tool called tslint that is really similar to ESLint and how you configure it and run it and things like that. So you install this tool once again via npm, and you can run tslint on the files, and we'll give you what you want to know. So there are a couple of ES6 considerations, though, when you're setting up your build pipeline. And the big thing is that TypeScript doesn't ship with a runtime at all. It is just a compiler. So what this means in practice is that all of the ES6 syntax can be handled by the TypeScript compiler, but the runtime operations cannot be handled by TypeScript. Specifically, what this means is there is no polyfill included for things like object.assign or the symbol constructor and other runtime features that were added to ES6. And this is a little different than Babel, for example, which does ship with a runtime you can include. In fact, it's called Babel-runtime in NPM that can polyfill these things. And so there's a lot of different ways you can polyfill it. You can get one-off polyfills for the things you're interested in. What I've seen most people do, though, and what I recommend people do, is you can configure TypeScript to compile to ES6 instead of ES5 code. And you put that into a directory, and then you pipe that into Babel and have Babel compile from ES6 to ES5. And then you can also include the Babel runtime with that, because those two work together really well. But that way you still get your ES5 output, but you can use all of the ES6 goodies as well. And this is also something to just kind of take a look at the runtime that you're operating in. If you're explicitly targeting Node 6 only for your application, then you don't really need to worry about it because ES6 supports pretty much everything in the ES6 runtime. But if you want to go back to, say, Node 0.12, or especially if you want to go back to Node 0.10, then this polyfill becomes a lot more important. So editor integration. Out of the box, both of the Visual Studio products, Visual Studio proper and then Visual Studio Code, support TypeScript without any modifications. Also, all of the JetBrains IDEs, or the main ones, WebStorm, PyCharm, and IntelliJ, they also support TypeScript out of the box. And then also most of the other editors support it with a plugin. So there are plugins for Sublime, Atom, Vim, Emacs, and a bunch of others as well. So we're at a point in time with TypeScript where if you want a really good TypeScript experience, you can still use the editor of your choice because chances are it will have really good support. So the biggest thing that people tend to deal with, though, is non-TypeScript modules. How do you use Express or request or sales or something from TypeScript? So TypeScript has a concept of a TypeScript definition file. And what this is you create a statically typed interface that defines what external dynamic code looks like. Oftentimes, this will be a slight subset. It may not be 100% coverage of the API, just because statically typed does tend to be a little more limited. But you end up with a really good statically typed interface you can work against, and then you can get all of your type checking and things, to make sure you're calling all of your express methods correctly. And so when you look at these definition files, it's a declaration, but it doesn't have an implementation. And for those of you who are coming from C++, it's a lot like a C++ header file. And so these are files, a normal TypeScript file has a .ts file extension, and then a definition file is one with a .d.ts, which means this is a TypeScript definition. And so if you look at it, it looks a lot like this. So we have this declare module, and we have the name of it. So this could be a declare module express in quotes. And then we basically define functions. But instead of giving it the definition, the curly braces with some implementation, we just add a semicolon. And so we just have the signature. We can also have interfaces in here and things like that. So everything looks like standard TypeScript on the inside, just without a definition. Now, of course, creating these by hand for all of your modules is really cumbersome and is a major hit on developer productivity. So we also have a tool called Typings, which you saw me briefly mention earlier. So Typings is a tool for installing and managing these type definitions. It's really similar to NPM in the way it works. You can install various definitions. These are versions, so you can install a specific version of a definition. So if you're targeting Node 4, you can install the version 4 of the Node definition files, or you can also install the version 6. Same thing with different versions of Express. You can go for Express 3 versus Express 4, things like that. And there's also a configuration file that kind of looks like a package JSON, in which we say these are the dependencies and this is the version installed at. So you can install things, save it to this file, and you can reinstall all of your type definitions with the simple Typings install, kind of like we do with NPM and dependencies and package JSON. And at this point in time in TypeScript's life, pretty much all of the common NPM modules have entries in the system. So unless you're using some of the more esoteric modules in NPM, chances are that definition file already exists. And so this is how we install that, just npm install Typings. And then to install Express, we would give it this command. So there are a couple extra flags in here going on. Typings is a tool that's been around for a while, and like the JavaScript world, it has evolved over time. There's a couple of different registries for storing these in. The big one registry is called definitely typed, and so that's what the source flag is. We're saying we want to install our dependencies from the definitely typed, DT source. And then this global basically means we're looking for a global module. It's kind of like a sort of a scoping things. Basically, if you're using definitely typed, it's always going to have the global flag. So I'm going to hand wave that away just a little bit. But then we install this, and we have Express. And then we can check in the typings.json into GitHub or whatever source control you're using. Then anyone else who needs to do it, you just do npm install, then typings install. Or you can work it into build scripts, things like that as well. So next, we're going to do a short little live coding demo. The source code for us, or the final version of the source code, is on GitHub. You can go to my GitHub repo, Nebrius, and it's need to node-TypeScript demo. And so what we're going to do with this is we're going to start off with the Express Hello World sample code. This is something that a number of you may have seen before. What this does is we use Express, we import it, and we create a single endpoint, which is the root endpoint, and then we just respond with hello world. And so we're going to convert this over to TypeScript. So the first thing we're going to do is take a look at this first line where we're importing Express. So this is the classic Node way to do it, and we want to convert it to the ES6 module way. So we're going to use the import keyword, and we're going to do star as Express from Express. So what the star is doing, this is a unique part of the ES6 module spec in which you can take all of the exports from a module and sort of wrap them up in an object. So this actually makes it look a lot like CommonJS. And in practice, whenever you are importing a CommonJS module into TypeScript or ES6 in general, this is typically how you do it, just have a little workaround. But once we have this, we then have the Express variable that we can use like we would any other time. And we'll change this to a const, just to use a little bit of ES6 features in it. And so then we're going to do, once again, just a little bit of a ES6 cleanup. And there we are. We've actually converted this to TypeScript. And so it's actually not very interesting looking. We can go over and we can compile this. And we're running TSC, and it works. We'll look at the package.json a little bit more to see that build script. So you can see we're just calling TSC directly. There's a few other things going on in here with scripts to make it easier, but we'll come back to that. And then we have our tsconfig, which you can see is the same thing we saw in the presentation. So I realize it's not very exciting because everything worked, but we can do something interesting. Let's say we misspelled send and we wanted to call it with hello world. Well, you can see that Visual Studio Code is not happy about this. It's saying send does not exist on type response. So it actually realized that we had a typo. And just to confirm that this is a compiler thing, we run the compiler, and ooh, we got an error. So once again, probably send does not exist on type response. So that typo is caught for us ahead of time. Some other nice things that TypeScript enables, that Visual Studio Code takes example of, which is what we're in right now, is when we type this out, we can actually get the signature as an auto-completion option. You can see it takes a body, which is optional, that's what this question mark means, and it can be of any type. You can also send a status, 404, things of that. And yeah, so this looks like basically regular JavaScript with a little bit extra, but we're getting the full benefits of TypeScript. Now, we're going to modify this a little bit more. We're going to split this into two separate files. I have part of it already written over here, so let's take a look. This is going to be a file that's going to handle this root route. And the idea is we're exporting a function that we're going to initialize. In this one, we do give it a signature, and we say this is going to take an instance of Express. We're importing Express up here, and it turns out the main Express class is exported on the Express object. So we can say app is of type Express. And so we get full auto-completion and things like that. So we're going to delete this line, and we're going to go over here, and we're going to say import init from root. And so now we have access to this init method, if I spell it correctly. And so this is kind of neat. I typed in init, and it actually gave us the full signature of the function that we want to call. And we even picked it up on that JSDoc documentation, which you can see gives us a little more description, which is really handy. So we're going to pass in app, and now we have a fully functioning app for across 2 files. So run build again, we see it succeeded. Now let's decide that, okay, so init is a generic name, and then we want to add another module. So, well, we're going to get a name collision. We can handle that with the module import, but let's say we want to refactor instead, because that's a little bit more fun. So we're going to go in here in init, and we say, well, we want to rename init from init to init root. So we type in this name, I'll hit enter. We see it renamed here, and oh, look at this. It says it made changes in index.ts as well as root.ts. We can go over here, we can see it automatically renamed init root in the imports and in the call right here. And so we save both of these files, compile again, and we see that it worked. So we got a refactor that we have complete confidence was done correctly, and it only took a couple of seconds. And so now we have a complete TypeScript application with a lot more type safety that's a lot easier to develop. And so that's the demo. So one last thing, I was showing you Visual Studio Code a little bit. I want to talk about it as a case study, because Visual Studio Code is actually, I think, really fascinating. Visual Studio Code is an Electron shell app, just like the Atom editor is, although a completely different code base than Atom that we wrote ourselves. So this makes it cross-platform. It also means that Visual Studio Code itself is written in almost entirely in TypeScript, and then a little bit of HTML and CSS. It's a very large-scale application. I checked this morning, and there are 280,001 line of TypeScript code in Visual Studio Code. And that's a pretty large project. We've had 133 contributors so far, which is pretty good for a project that is only about 2 years old. And so it's really interesting the way this has developed. Since we were basically dogfooding our own language, well, Visual Studio Code improved as a TypeScript editor, and TypeScript improved as a language for doing large-scale web applications. There's this wonderful symbiosis that happened between the two. And it turns out it's been that maintaining has turned out to be pretty, well, about as easy as a large-scale project can get anyways. It's really, TypeScript has really aided us in creating a first-class editor into what I think is the best editor kind of in that class of editors these days. And I know I've worked for Microsoft, so I have to pitch Microsoft products a little bit, but I actually started using Visual Studio Code about 8 months before I even thought about joining Microsoft. So I've been a fan of this editor long before I've been a Microsoft employee. And TypeScript has been a really important part of the success of Visual Studio Code. So we know what it looks like using it on a large-scale project. You can learn more about TypeScript at typescriptlang.org. There's a lot of tutorials there, getting started guides, as well as language references as well. So you can really dig into a lot of the details and a lot of the other really fun options that TypeScript has. And at this point in time, I will take some questions.
Awesome. Thank you, Bryan. That was excellent. Learned a lot. All right, we have quite a few questions here. Start with a simple one. So you mentioned the Node 6 versus Node 10 versus Node 12. Question was, how about Node 4? Is the recommended path to go and transpile through Babel since the ES6 support in the LTS release is not complete?
I think that's a question you need to figure out as a team. It depends on what features you want to use. So Node 4 does have a reasonable amount of ES6 support. It just kind of depends on how much you want to go into it. Well, at least from a runtime perspective. So like the things that people commonly use are generally there.
Right.
And anytime you do add an extra compile step, it can make build chains a little more complicated. There's always a chance of tooling kind of breaking a little bit. So I think there are, Yeah, I realize I'm not actually giving you an answer here.
Sure,
But just, I think
Right. Thinking of that list that you shared, proxies would be out,
yeah.
symbols would be in. So a fair number of the native implementation is going to be there. I guess start simple, stay with TypeScript until you hit the limits of it, maybe.
Yeah, I think that's a good approach, and it will become pretty obvious too. Because you're going to get everyone's favorite error, undefined is not a function, pretty quickly on that. But at the same time, if there's something that you don't really want to mess with, you don't want to go and analyze, oh, what features do we want to use, what don't we use, and you're fine with increasing the size of your code base a little bit with always including these polyfills, maybe taking a slight performance hit on occasion, depending on how the polyfill is implemented, then you can just go ahead and implement it. Just go and use Babel and not worry about it.
Right on. All right, so a couple questions about testing and unit testing with TypeScript. Is there a preferred approach, pure preferred setup, Mocha or the like, or is there a TypeScript-centric unit testing framework?
So there is not a TypeScript-specific unit testing framework or a TypeScript-centric one. One of the main design goals of TypeScript is to be one piece in a larger toolchain. So it really is comparable to Babel, which also doesn't have a preferred unit testing framework. On the team that I work on, we use Mocha for our testing. You can use Jasmine if you want. For those of you who are Jasmine users, NodeTab, NodeTape, pretty much anything you want. Just as long as you can set up a proper build toolchain in front of your test to get things compiled first, TypeScript works great with that.
Fantastic. So technical question from Dan, not this Dan. How does the TypeScript compiler translate private class methods internally?
Oh, that is a good question. I'm actually not certain on that because I don't work on the compiler. If I were to guess, though, the typical usage for TypeScript, though, is to compile back to ES5, not ES6. Okay. So, if you have that enabled, it's not going to use symbols, if that's kind of what you're asking at. So, if I were to guess, once again, I don't know for certain, I would imagine it's probably creating some temporary underscore variable name. If you want to make sure that you are using symbols, though, then I would definitely tell TypeScript to compile to ES6. And then if you need to, use Babel on top of that, which gives you a lot more control over exactly how the code is being compiled. But that's an interesting question. I want to go and research and find out now afterwards.
I know. So Lewis asks, for microservices, one of the goals of when he's building microservices is to keep the number of lines of code to a minimum. Is there still a benefit in that case with having TypeScript in the toolchain?
I would say so, yes. And actually, in a microservices case, it can become even more useful. So, with microservices, lots of different processes, they're communicating over HTTP. Typically, maybe it's a socket, but it's some sort of networking layer. So you're getting these messages coming back and forth. And so with TypeScript, there's the concept of an interface. What you can do, and by the way, this also applies to if you're listening to events, same concept. You get your data out, just as soon as it's been, JSON parsed or however you're doing your parsing, and then you can pass it to a helper method, and you can have that interface definition from, wherever that message is coming from in your source code that's consuming it. And so that way you can make sure that, the way you're using that data conforms. And so there's, I think, a couple other things you could probably do as well. If you're using NPM or NPM private modules or something like that to deploy your microservices, you can version that out, and you could just include with that TypeScript inside that module, like your TypeScript definitions or your interfaces as well, and you can import that into other modules. At least that's one approach. It kind of depends on the specifics. But yeah, I think it's definitely handy being able to say, well, I've got this interface, and I know this data coming in from the network is going to conform to it. And as long as you're using that interface definitions on both, the one producing the message and consuming, you can actually still be guaranteed that you know what that data packet looks like.
Right. Yeah, reliability, integrity of microservices and microservice definitions. Definitely a lot of value there. So a question from Arturo. Can or should you use a linter like ESLint with TypeScript? Does that still make sense with TypeScript?
I don't think so, because TSLint, it's very similar to ESLint. It has a lot of the same rules.
Okay.
I don't know exactly what the overlap is. I have to run numbers on it, but it has a lot of the same rules. So it's not just looking at TypeScript specific things. It can also do things as far as aesthetic style. How do you are you one true brace method? Do you prefer brace on different lines? Single versus double quoted strings? All those kind of normal ESLint-like things are also in TSLint. And then TSLint also has TypeScript specific stuff. So TSLint, I think, serves as a good replacement for ESLint.
Great. So I can hear the Java trauma coming through in this question. So are there any tools in VS Code to attempt to write DTS files based on a vanilla JS class? Could you stub out the variables and objects that need to be defined?
There's not one that I'm aware of. That doesn't mean there's not one that exists, but I haven't heard of it. That is a much more difficult problem than in Java, I think, just because types are optional. Well, I should back that up a little bit. In TypeScript, there is an option at which you can say no any types, which will say you always have to have a defined type.
Okay.
If that were enabled, it should be possible to write such a tool. But because that option exists and that you can have vanilla JavaScript, and with vanilla JavaScript, you just can't infer that definition. JavaScript's just too dynamic. So, yeah, I'm not saying the tool doesn't exist, but it is a much harder tool to write than it is to write in Java, unfortunately.
Got it. So Mauro asks if you can already use async await syntax in TypeScript.
So async await is not in TypeScript to the best, or last time I looked at it. Now, it might be in TypeScript 2, which is on the verge of coming out. But generally, it tracks more like what is the published standard. And async await, wasn't a part of ES 2015. My understanding, it's on track for 2017 though. So we should be getting that soon if it's not there already. But it is kind of a new thing. And of course, async await is a little complicated because you also need runtime support. And so TypeScript, at least TypeScript 1.8, which is the latest published version, doesn't have a runtime. So yeah, it's not going to have async await support.
Okay. Just for anyone that is watching that has a new question come up, I'm going to have to ask you to post your questions to Twitter with the hashtag #NeedToNode. I basically have too many questions to fit in to the next 5 minutes. So thank you for all the great questions today. But we're going to have to sort of hold stop on the incoming questions, and we'll follow up and catch anything on Twitter. So a question about plain JavaScript files. How does TSC treat plain JS files in a project?
So if it's a file with the .js extension, it can still analyze them. The actual TSC command, the compiler command, will just ignore them. So you don't get any benefit from that. Now, an interesting little caveat to this is if you're using Visual Studio Code, Visual Studio Code, if you've used it for plain vanilla JavaScript development, you actually get autocompletion and some error checking and things like that. Under the hood, it's actually running the TypeScript compiler on this vanilla JavaScript code. It has just a couple of things turned off with around like external modules and a few things like that. So it like relaxes the rules a little bit. But if you're using Visual Studio Code at least and Visual Studio, you can still gain some benefit, especially if like some things are TypeScript and some things aren't, because it'll just try its best to infer what it can. But yeah, as far as vanilla JavaScript files from the command line, the compiler ignores them.
How readable and debuggable is the actual generated code? So, what Node's reading, not the source map.
If you look at it, it's pretty similar to Babel's output. TypeScript tries to make it pretty readable. I think Babel does a little bit better job, but it looks pretty similar in that you'll see a couple extra temporary variables here and there that will, that are used to handle some of like the transitions and whatnot, especially around importing modules. And so it's usually you'll see some sort of name you kind of recognize, and then like a couple extra symbols tacked onto it to make it unique. Now another option, of course, is if you're going from TypeScript to ES6, it actually looks the same just without the type annotations. So if you're going to ES6, it's incredibly readable because it's literally just stripping out the annotations.
Great! Can't wait to get on get Node 6 to LTS.
I know. I'm excited for that too.
All right. So Dave asks, and maybe we touched on this question earlier, but I want to go ahead and see if we can suss this out. What are your recommended approach for efficiently generating TypeScript definition files that don't already exist? It's a little bit similar.
Right. So the way I would recommend it, there's two. It depends on what you want to use them for. Let's assume that you want to use this in your own personal project. You don't want to publish it to the definitely typed registry. Which, if you're going to publish type registry, it is a public registry. You can publish just like with npm. In that case, in both cases, you want to go through the original module and generate it by hand. Unfortunately. Just because there is kind of some interpretation and room for interpretation over what we think the static interface should look like.
Right.
Just because the static types don't exist, and a lot of times figuring out what it should be it's a matter of opinion, really. But if you're using it in your own project, what I recommend doing is figuring out what parts of this module you want to use, and only define the interface for that. Because you can definitely, if there's parts of the API you're not using. There's nothing in TypeScript that says you have to document them. If the TypeScript compiler never even sees you referencing this property, it's not going to be any the wiser. So I recommend only doing what you need and grow it up incrementally. That way, you don't spend a whole lot of time creating these type definition files.
Got it.
And once you get used to TypeScript interfaces, it's actually not very hard either.
So riffing on that question, I know Dave is a library author. So, how should library authors approach TypeScript, and what's the best way for them to interact with that ecosystem?
Mm-hmm. I'd say if you're a library author, definitely maintain that TypeScript definition. Because as the author, you're going to have a lot more insight into how the API works and sort of what the intended use is. So going back to those opinion questions of what it should look like, you should have a much more just inherent understanding of what that should look like. So I definitely say maintain it. You can maintain it within the same repo. You can maintain it in a separate repo as well. What some people do is depending on what your documentation is, if you're generating your documentation from like YAML or some other format like that, you might even be able to set it up so that the TypeScript definition is automatically generated from that. Forcing your And the great thing about these TypeScript definition files and maintaining them is it forces you to think a little more carefully about the types that your API accepts. So it can actually benefit your documentation for just vanilla JavaScript users as well.
Right.
So kind of going through that exercise of documenting your types in YAML just for your regular documentation, so that it can generate TypeScript documentation, just kind of helps everyone out all around.
Perfect. Makes sense. So last question, I'll weave in kind of a bonus question as we go through this. So any experience using TypeScript with something like React? There's a lot of pain experience in trying to get that Angular that working. A lot of examples for Angular 2 where TypeScript is supported natively.
Right. So this is a story that has evolved quite a bit over the last 6 months or so. So if you're using TypeScript React in like the TypeScript 1.6 days, yeah, it was kind of painful. Angular 2 coming out really forced us to improve our tooling. If you're using TypeScript 1.8, the story is much better, and TypeScript 2 is going to be even better. So in the React case specifically, when we say React, I'm going to assume you're meaning JSX syntax within JavaScript. That is absolutely supported. And because of those static typings, it's once again, you actually get really good autocompletion even inside of JSX, which is actually really handy. So I think they make a good pair, especially now that the TypeScript tooling around it has matured to a point where it's really usable. But yeah, if you are using an older version of TypeScript, and by older I mean more than about 4 months old, or 3 months old, I would definitely look into upgrading to the latest version because there's been some good improvements in that. And keep an eye on the futures. Once TypeScript 2 hits the mainstream, that's going to help quite a bit as well.
Fantastic. Well, thank you, Bryan. It was very insightful. Learned a lot today. And thank you all for joining us. We'll be back next month with Node Source. In the socket, we'll have Nathan White leading a webinar. Details of that will be up on the site soon. Thank you once again, Bryan, and the entire team at Microsoft for helping make this possible. Thanks a lot.
Thanks, everyone.
Yeah.